Good morning, everyone. So, today we start our paleontology class. This is the first class of the paleontology branch within the subject geology. Now, what do you mean by paleontology? Before studying or going into the details of the paleontology, first you have to know what do you mean or what someone mean to say about paleontology. Basically, the term paleontology is made up with three words. The first one is onto, and the third one is the logy. So together these three words combine and formulate the terminology or formulate the define the subject as paleontology. Now the term paleo means, as you all know, it means ancient. So anything beyond past with respect to the present day. Second is onto, which means living beings, and third one is logic, that means logical approach. So if we combine all the terminologies together, then it means a study or logical study of the ancient living beings. So the study of ancient living beings in terms of some scientific approach is known as paleontology. Now, a student may ask, why should we study paleontology? The first thing is that the ancient living beings, obviously, the terminology living beings for an ancient organisms which is not at all living is a vague term, and that is mislead us. Basically, it's the remnants of the ancient organisms which live in that time. uh, they are preserved in the rock record, which we called as fossils. Basically, the study of fossils, that is the ancient organisms, is known as paleontology. Now, a student may ask you that why should we study paleontology or why should we study fossils? What will I get from this class? What scientific information it will provide us to understand the history of the earth? The first and foremost main uh, scientific reasons or scientific informations what you get by studying paleontology. Apart from this, there are several minor informations are also get when you study the subject paleontology. The fifth thing is people study paleontology due to simple fascination, because uh, you are also studying the biological part in your subconscious mind, because whenever you go into some beach areas in the um, near conditions of any sea, you will find different shells of bivalves and gastropods, that is different types of shells, different colored of shells of your shamuk and chinook. So whether you know about their um, biology, or whether you know about their ecological conditions, whether you know about their habitat, most of us, we all did not know about these things, about the biological aspect of those cells. But instead of that, we are collecting those cells. Why we collect? We did not know anything about those organisms, about those cells, but still we collect. Sometimes we buy from the nearby shops. That is because they are very attractive, and because of their attractiveness, We sometimes collect them. We sometimes study the minute things or the broad things, such as their shape, such as their color. Those things are studied and noted. So, simply due to fascination, people love to do that. They will also study the subject paleontology. And lastly, that is proposed by me for the students, you have to study paleontology whether you like it or dislike it, um, to get your graduation degree, because there is a subject called paleontology in your syllabus, and it have a pretty much marks contribution in your total number of your undergrad study. And if you are not able to pass this subject, then you will not get the degree. So whether you like it or not, you have to study. But uh, this subject is very much interesting if you try to understand the basic things, the basic phenomena behind it. Now, here is showing you two pictures. The first one is a baby woolly mammoth, uh, and the second one is a mummy. Now, can you say which one of these two is fossils, whether it is a baby mammoth or a mummy? Because we all know that all these things are not present during this time. A baby mammoth present in the earth about 20,000 years ago. Whether as a mummy is a human, but these humans present far ago from the present day times, and they are mummified after their death. So this dead body present within these coatings, they are not of present day time. So that is why I called it these are ancient um, human bodies. So which one is fossil, a mammoth or a mummy? Now you have to answer this question. So whenever you try to answer this question to your closed ones, if someone asks you, okay, you are studying paleontology, so tell me whether a mammoth, between a mammoth and a mummy, which one is fossils? So you have to think uh, from the scientific point of view. You cannot answer randomly, but you have to think from a scientific point of view and justify to your answer by some logical approach. So you have to be a detective to find out the clue to say any particular thing, that is to say whether the mummy is a fossil or whether the woolly mammoth is a fossil. So before giving answer to anybody, you have to identify the clue, and you have to give them a scientific reason due to which you called some one a fossil. So basically you have to um, follow a detective's guide. Now what is a fossil? So in its earlier times, that is in the Middle Ages, basically the word fossil applied to any specimen. Basically it comes from a German word uh, which means exceptional preservation or exceptionally found. Now, in the Middle Ages, the term fossil is applied to any specimen which is dug from the ground surface. So it may be an ancient living being, or it may be a mineral, or it may be sometimes people dug for uh, water to uh, establish any tube well. So the question comes, if we dug uh, for water and establish a tube well, then can we call water as fossil? Because in those times, uh, anything which is dug up, that include minerals, rocks, ancient organisms, are called fossils. So people are misled by the term, that whom should we call fossils or whom we do not call fossil. By the 18th century, the word gets its uh, precise meaning. That is, we call fossils only to those things which belongs to some ancient living entities preserved in the rock. So you can see that whenever we called that, and for the term fossil is only applicable to the ancient living beings, that is their cells or any part of their body, then automatically we are discarding these things. So only the ancient living beings or their remnants or their traces are called fossils. Now, if we try to define the term fossil in proper scientific language, then fossils are the remains of ancient organisms. It may be the complete organisms or it may be part of the organisms, uh, but it will be the remnants of ancient organisms or the traces of its activities must be preserved under natural condition. So three things you will get from this definition. First, it must be remnants of ancient organisms. That may be the complete remnant, complete organisms preserved, or part of the organism preserved. Both are called fossils. Or sometimes the organism is not at all preserved, but its activity is preserved in the rock. Suppose you are running over a sandy surface and your footprints are following you. So you are moving in the forward direction, but your footprints stays behind you. So if someone want to study your footprints, then they can say that some human being is running over this sandy surface just by studying your footprints. So those footprints are basically indicate a activity done by you. So in those cases, those activities, those traces which are indicative of certain activities of any organism are also called fossils. And all these things must be preserved under natural condition. So now, from the detective's point of view, you can very well answer about the question whether a woolly mammoth is a fossil or a mummy is a fossil. You know that woolly mammoth, those baby woolly mammoth are found in the Siberian frozen landmass, Siberian ice, Siberian glaciers. So that indicate that woolly mammoth is preserved naturally. But the mummy, which is the dead body of some ancient human, they are preserved by some man-made processes. People use some kinds of chemicals, some kinds of bandages to preserve the dead bodies of that time. So that is not a natural process. That is why a baby woolly mammoth is a fossil, but the mummy is not a fossil, because the mummy does not satisfy these conditions. So whenever you called an ancient uh, remnant of ancient organism a fossil, you must be very much aware that that is preserved under natural condition. Now, fossils is basically reading a story from a ancient diary. There are many things written on the diary in page wise. So you have to understand that writing and you have to study uh, those writings very carefully. But it often happen that in an ancient diary many pages are torn up or many pages are actually missing. In natural world that is also happen. We all know from our previous classes that anything which is deposited in any time, their preservation is very rare, but being not preserved is the most common thing. So anything living being present at any particular time interval, uh, whether they will preserve and going to the fossil record or not, that is simply a chance factor. So it may often happen that many fossil evidences, many organism evidences of ancient life, they are destroyed in due courses through time. So whenever you try to study the fossil diary, try to study the fossil evidences from the sedimentary rock record, that is try to study the um, organisms through time, you must be very much careful uh, whether all the pages of the diaries are there. That means whether they are a continuous sequences of fossil evidences, uh, or some there are some missing things in the fossil. In most cases, or it is very common that the fossil record is incomplete. That is, most of the organic evidences are not preserved in the rock record. But still, it's very interesting to someone for someone who love the organic world, because it tells us many things, many informations um, about the ancient organic world, as well as it tells us how we came and how long will we sustain in the present day earth. So just as a police detective, you have to use the clues, um, what happened at the crime scene, that means what happened during the deposition of the sedimentary rock, and you have to figure out the story behind those uh, organic bodies, ancient organic bodies. So those peoples who study these ancient organisms are known as paleontologists. So the subject is paleontology, and those people who study paleontology or who do research in the subject paleontology is known as paleontologists. Now, paleontology can be branched into several sub branches where the ancient plants are studied, that is known as paleobotany. When ancient organisms are studied, it is known as paleogeology. And when the organic evidences, the organism bodies are not at all preserved, instead their traces of activities such as the footprints, those are preserved, and from those indirect evidences we try to estimate about the real organic world scenario, that is known as ichnology, that study of traces of organisms. Now, paleozoology can again be divided into two branches. One is the invertebrate paleogeology, another is the vertebrate paleogeology, depending on whether the organism, whether the animal body have vertebral column or not. So this is the broad divisions of paleontology. Now paleontology can be again subdivided into two halves, whether they are studied under naked eye, that is in simply naked eye or with the help of pocket lens, or the evidences of organisms or the details of organisms are studied under the common petrological microscope. So when they are studied under microscope, they are known as micropaleontology. When they are simply studied under naked eye, they are known as macropaleontology. Now, what are the types of fossils which we are studying during a study of paleontology? So, three types of fossils are classified. The first one is the body fossil, when the entire or part of the original body of the organism is preserved, and that body means that you may very well aware that simply if you consider the body of human being, and the human bodies consist of several hard parts, those are the bones, cartilages, and several soft parts, several muscles. So any body of an organism, and in most cases the body of an organism consists of two parts, the hard parts and the soft parts. In body fossil, they both may be preserved, that is the hard parts and soft parts both may be preserved, or uh, only the hard part or only the soft part can be preserved. But it is found that whenever an organism died, the first thing is that um, the soft part of the organism, that is the muscles, tissues, they are decomposed. You may often find a dead um, body of an animal, a dead body of a dog or dead body of a goat in the roadside. So you will find that after some days it will smell terrible, and this smell is because due to the decomposition of the muscles of that dead body by some decomposing bacteria. But um, when the decomposition of the soft muscles, when the decomposition of the muscles is complete, still the hard parts, the bones remain as it is. So generally hard parts have more tendencies to be preserved, more chances to be preserved compared to the soft parts, compared to the muscles. So when you consider a body fossil that consists in the entire body or part of the body or it consists only the hard part of the organisms, or it consists the hard part and soft parts of the organisms. So any part of the body or the entire body of the ancient organisms, if it is preserved naturally, then we call them as body fossils. Mind it, whenever you have to define body fossil, you have to mention that it is preserved naturally. That is the first and foremost criteria to call it a fossil. Okay. Second is the trace fossil. As I already told you, in trace fossil you are not getting the direct evidence of the body parts of any organisms. Instead, you are getting some traces of any kinds of activity of the organisms. Say, for example, the footprints of any living being running over any soft sediment, and after they ran away, those footprints are preserved in the sediments, and in due course, in the latter time when those footprints are discovered in the rock record, it indicates that certain kind of animals are run away over this uh, sedimentary horizon. So those footprints indicates the running activity of certain kinds of animals, and uh, you may know that the footprints, the periphery of the footprints or certain measurements of the footprints, from though that you can basically uh, estimate the height or the body weight of the organisms. So footprints are also indirect evidences of organisms activity, as well as the shape or the height of the organisms. Yeah. And the third one is the chemical fossil. It is also an indirect evidence of organic body present in those times, present in the during the deposition of those sediments. Basically, instead of getting any body part or getting on traces of activities, here some chemical components of the organic body mixed with the sediments. And whenever we study the chemical components, that is whenever we study the chemical analysis of those sedimentary rocks of that particular point, or that particular area, we get some anomalies in this with respect to the surrounding sediments of the same bed. Say for example, you are walking around a road and somehow your finger is cut, so some bloods are going out from your hand, and that blood drops are fallen on the ground surface. So that blood is basically chemical component, and it is mixed with the sediments of that particular point. So in that particular point, if you do some chemical analysis, you get some abnormalities corresponding to the other places where those blood drops are not mixed. So that is an indirect chemical evidence by which you will get an idea that certain kinds of organic activity is going on over here. So those in those cases they are called as chemical fossils. Those chemical traces are known as chemical fossils. Here you can see a body fossil of Archaeopteryx. You can see that all the hard parts, all the bones, along with the soft parts, that is the feathers, they are very well preserved. You can very well say these feathers. these feathers. They are very well preserved. So there is an body fossil almost entirely present. Only the soft muscles are not preserved. Here again, a body fossils, some reptilian egg. This is an egg, and within this egg, the embryo uh, died and they preserved. So it is not um, this egg shape is not formulated, but it is the original egg in which within this egg somehow the embryo died and it preserved. So you can see that all the bones are already formed. Only thing the muscles are not preserved. So it is also a body fossil where the hard parts are preserved. Body fossils where only the soft part are preserved. This soft part preservation is an unusual thing. In most cases, after the organism dies, the readily decomposed thing is the soft part, that is the muscles, tissues. They are readily decomposed because the decomposing bacteria readily acted over them and they destroy all the soft muscles. So whenever you find a soft part of any organism, that is the muscles or tissues of any organisms, they are very rare and they must be preserved in an unusual case, such as this Siberian woolly mammoth that is completely trapped within the glacier. So as it trapped within the glacier, um, there the decomposing bacteria cannot approach to this dead body, and due to that all the soft tissues with the skin of the mammoth and the hairs are all preserved with this woolly mammoth. Another thing is a amber, that is the resins from certain plants. Within this amber, certain kinds of fly or certain kinds of insects are trapped. So it becomes a closed system in which the external affairs cannot affect this dead body now. So the decomposing bacteria cannot get access to act on this insect. So you can see that all the soft body along with the wings, they are all very well preserved. And so, in just few days ago, I somewhere I learned that from these insects, the bloods are also collected. This type of insect from a place, the bloods are also collected. Now these are trace fossils. Here the original organisms is not preserved, but their activities are found preserved in the rock records, such as the dinosaur footprints. You can see that a dinosaur is walking over this sedimentary rock, and all the footprints are preserved here. So in the present day, when these human beings is there, there is no dinosaur, but you can say that during the Mesozoic times, uh, instead of human, here lives dinosaurs, and they are walking over here, and their footprints are preserved in this sedimentary rock. So from this footprint, you can get an idea about the size, shape, and the ecological condition, and many other things of the dinosaur. Here you can see a burrow, that is a organic body which lives under the surface. It dig the soft sediments and make a passage to enter deeper part into the sediments, and in later stage this passage is filled up by the overlying sediments. So you will get some tubular sediment filling. These are called burrows. These are also indicates about the um, underground habitat condition of any organisms. This is the home of the home of any organisms. These are the crawling marks of an arthropod organism known as trilobite, They crawl over the surface, and during their crawling they make some these kinds of furrows and ridges. So from that you can sometimes say about the size of the organisms, the direction of moving of the organisms, and all these things can be said by the traces of the organic activities, although the organic body is not found in these cases. Third, the chemical fossils, where chemicals are found within the rock, which gives indirect signature of ancient life. The chemical evidences are the organic molecules which mixed with the sedimentary rock during their decomposition on some isotope ratios. Whenever an organic body lives in there, it excretes some excreta which mixes with the sediments, and some kinds of isotopes ratios are changed. So presence of those isotope or study of those isotope ratio can give you the indirect evidence of certain organisms present during that time. A very good example is the fossil fuels, that is the petroleum or coals. The fossil fuels comes from the marine planktons or marine organisms, marine animals, whereas coal comes from the plants. Uh, so although in petroleum or in coal, at many times you will not get the directly the organic body, but instead of that, whenever you get these um, things from the subsurface, from the rock record, you can be pretty much sure that during some time interval these types of organisms live in these areas, and after their death they are deposited, and with due time they uh, got some modifications, they got some changes into them, and ultimately they form petroleum, or ultimately they form coal. So these are the chemical evidences of biological remains or chemical evidences of biological bodies present during that time. These are known as chemical fossils. Now, factors affecting the fossilization: the structure and composition of the original shell of the hard parts. First of all, I already told you that a organism having hard parts and soft parts, the hard parts are more favored. If you compare an organism having hard parts and soft parts and another organism having only soft parts, then definitely the organism having hard parts and soft parts, they are favored, because after the death of those two organisms, the soft parts are decomposed. So the organisms having both hard parts and soft parts, if their soft parts are decomposed, then also their hard part remains, so those hard parts can be preserved. But if an organism consists only soft parts, after their death, if the soft parts decompose, then the entire organism is lost from the history. So anything of that particular organism is not preserved. So always hard part bearing organisms are favored um, to be preserved in fossilization. Among hard parts, certain kinds of stable minerals are favored in fossilization, such as the calcite, um, which is a polymorphic form of calcium carbonate. Another polymorphic form is aragonite, but aragonite is not um, a stable mineral. Rather, calcite is very stable. Silica, calcium formate, these are the stable minerals. So when an organic body's hard part is made up of these mineral components, they are most readily preserved. Second is the nature of grain size of the enclosing sediment. So whenever an organism died, they have to be deposited uh, within a sediment basin, and they have to be covered up by certain kinds of sediments. Now if an organism's um, died in an high energy condition, suppose in the fluvial region in the Himalayan terrain. So that is the high energy fluvial condition. If an organism died there, so due to this high energy condition, the larger size clasts are deposited there, and in most cases the organism is destroyed during its transportation. But if an organism dies near the Bay of Bengal or near the Arabian Sea, close to the basin, um, here only the fine grains are deposited, so it's comparatively a calm energy condition, a very low energy condition. And here, due to this low energy, after the death of an organism, they can be preserved. Chemical condition and the time of sedimentation, definitely after the death of an organism, the chemical conditions required is the low oxygen condition, because in presence of atmospheric free oxygen, the decomposing bacteria act readily on the soft mass or soft tissues of the dead body, and when they act on those dead bodies in presence of oxygen, they completely destroy the body, no evidence left behind. So if an situation arise when there is low oxygen, or where there is devoid of atmospheric free oxygen, then the chance of preservation of that organic body is highly favored. So how these low oxygen conditions can be reached? The very um, easy way to reach the low energy condition is rapid burial. That means immediately after the death of the organism, it will be buried under the sediments. So definitely, uh, if rapid burial, quick burial of the dead body by sediments occur, then surrounding that dead body, it is completely covered by the sediment. So less amount of free oxygen was there. So chance of getting decomposed becomes very less. So rapid burial definitely indicates that the sedimentation rate in that area must be very high. Whenever in a basin, in a depositional setup, the condition suffers a high sedimentation rate, then the chance of preservation of the dead bodies of the organisms of those areas becomes very high. In comparison, a basin where the sedimentation rate is very low, then after the death of the organism remain exposed for a prolonged time in free oxygen condition. So during that time, the decomposing bacteria acted over it and they destroy the organic body. Now, this free oxygen does not mean that it is the only atmospheric oxygen. Free oxygen can present in atmosphere as well as in water. So it does not mean that the organisms after their death deposited underwater condition, that means it will not in presence of free oxygen. In underwater also there are free oxygen molecules. So organism, those decomposing bacteria can act in open atmosphere as well as underwater in the same way. So for creating a low energy condition, the first and foremost condition is the basin should have rapid burial. That means high sedimentation rate. And the last one is the diagenesis during lithification. That means all the changes occurred after the deposition of the sediments. Those are known as diagenesis. That is, after the deposition of the sediments, they are going to solidify and form some kinds of sedimentary rock. And during this solidification or lithification of sedimentary rocks, they are suffering certain kinds of changes, and these are known as diagenesis. So this diagenesis also affects the preservation of the fossils of the ancient living beings. So all these factors, they are um, play a havoc role whether an ancient organisms will be preserved and going to the fossil record or not. If any condition of these uh, things are slightly negative, then in most cases you can have an idea that with slight change of any condition, it is most commonly that the organic world, organic body will not be preserved, and we will not get any evidence of those and living being, or will not get any kinds of fossils. So the organisms living in the sea floor, they are, after their death, they settled in the um, ocean bottom, whereas an organisms living in the land surface, continental land surface, after their uh, dead, they have to be transferred and getting deposited into the basin. So during this transportation time, they are exposed to the open free oxygen condition. Why they have to transport? Because that is the condition, that is the base level of erosion, the mean sea level, that is the base level of erosion below which no erosion occurred. So an organisms living there, after their death, it will be deposited here, but that deposition is not permanent. In sufficient energy condition, the organism's dead body move towards the downslope region. Only it will not suffer any further erosion when it is deposited below the base level of erosion. So below the base level of erosion, that is below the mean sea level, there will be no erosion. So the any organisms deposited below mean sea level, and uh, their exposure to open free oxygen is very less, because they have not not to suffer any kinds of transportation um, before going to the below the base level of erosion. Okay, but again, after deposition in the after deposition below the base level of erosion, they must be readily covered. That means they have to suffer a rapid burial rate, quickly buried by the sediments, so that the decomposition bacteria can uh, affect very lesser amount to that organic body. So the organisms living uh, below the base level erosion, they have more chance to preservation, whereas the organisms living above base level of erosion, they have relatively less chance of preservation or less chance of fossilization. So these are the books you have to be followed in this for this class study material. The book by Peter Doyle and the book by Clarkson. They are very good books, and they are uh, required in other paleontology classes also. Thank you. That's a brief introduction of paleontology. What is paleontology, and how paleontology inform us about the ancient world, or about the ancient living being, and why should we study paleontology? That is the most important thing. Thank you.